Hey guys, how you doing? In this module today, we're going to walk through completing how to go about assembling a cylinder head or installing it on an engine. So let's get started. On the left side here, you should see a folder called Service eLearning. You may also see it in the middle. And then down at the bottom, you'll see Day 10 assigned to modules, and you also see it in the middle there. And we're going to go to the one module that's there called Cylinder Head and get started. Now, it starts off by introducing us to the cylinder head. It says the cylinder head is bolted to the top of the engine block. It seals the cylinders and houses the valve mechanism. Usually the cylinder head is made from aluminum, alloy, or cast iron, but you may also find cylinder heads made from magnesium alloy. The camshaft opens the valve, and valve springs ensure the valves close. That's the part we talked about last week with what the cam does. And then you guys with your engines that you took apart, took off all the cylinder head bolts, and then previous to that, you took off the timing belts, and then took off the bolts, and then took off the cylinder head. So this is going to walk us through servicing that part. So first thing it wants us to do is select the valve cover, and that's going to be the black part on top here. Then we have our engine block down at the bottom, the blue part. And then we've got our cylinder head right here. And we'll go to the second one. It now says click the valve cover to take a closer look at the cylinder head. So click on the black part here. And now you're going to see this part inside of here. I'm going to ask you guys, what's that called? It is the camshaft. Which material can be used to make the cylinder head? And it listed all that right here, these three options. So it's not bronze. It could be cast iron. It could be aluminum alloy. It's not going to be copper. It can also be magnesium alloy. And definitely not plastic, or at least not yet. Now we're going to click on the camshaft to put it into motion. So click on the part here. And now you're going to see that camshaft going around. You're going to see the camshaft lobes we talked about last week, pushing down on the lifter, down on the valves to open and close those. And this cylinder head is what houses those camshafts. And we'll go to number 5. What is the function of the camshaft? And it says right here, the camshaft opens the valves, and the valve springs ensure that the valve closes. So it is going to be to open the valves. And it's up to the valve spring to close them. Now we'll go to the second one at the top. So in regards to cooling and lubrication, combustion of air and fuel will cause the cylinder head to become too hot if not adequately cooled. Therefore, passages are machined into the cylinder head to facilitate the flow of coolant, so heat can be carried away. Oil passages are also machined into cylinder heads to facilitate lubrication of the valve mechanism. So, number 1 says, click the cylinder head to view where coolant and oil flows. So click on any part right around here. And now you're going to see the green is the coolant, the liquid that flows through there. And the brown is going to be the oil that goes through it and is sent to the camshafts where the bearings are here, and then also to each of the lifters to provide them with oil pressure. And we'll go to the second one. Click the different areas where liquid flows. So the brown line is going to be the oil, and then all this green area, and there's a lot of it because there's a lot of heat. All the green area is going to be the coolants. And now we'll go to the third one. Why does coolant flow through the cylinder head? I'm going to ask you guys, why does it go through the cylinder head? We know it goes through the block, but why would it go through the cylinder head too? And it's going to be because combustion of air and fuel causes the cylinder head to become too hot if it's not cooled. So this one right here, the cylinder head becomes hot due to combustion. The flow is used to carry away heat. And now we'll go to the fourth one. Why does oil flow through the cylinder head? Right here it says oil passageways are also machined into the cylinder head to facilitate lubrication of the valve mechanism. used to lubricate the valve mechanism right there. And we'll hit check. And now we'll go to the third one at the top. And now it talks about the cylinder head gasket, which is this big portion right here. And that's what ultimately seals the block to the cylinder head. So the cylinder head gasket, or head gasket as it's commonly called, is fitted between the top of the block and the cylinder head, forming a seal between the two parts. The head gasket seals in combustion gases, as well as coolant and oil that pass between the block and the cylinder head. The sealing surface on the cylinder head must be perfectly flat in order for the head gasket to properly seal. The flatness of the cylinder head can be checked using a flat edge and feeler gauge. And that was something we did on the small engines, and then we also did it on our Honda engines. The number of punched holes or notches at the edge of the gasket are an indication of the thickness of the gasket. So the first thing it tells us to do is click on the head gasket. So we're going to select anywhere along here. And we'll go to number 2. And what is the function of the head gasket? And as it's set up here, it forms a seal between the two objects. So it provides the correct sealing between the engine block and crankcase. Well, that part's not true. Provides the sealing between the cylinder head and valve cover. That's not true either. Provides sealing between the cylinder head and the block. That is going to be true. And we'll go to the third one. Click a cylinder head opening in the head gasket to view the head gasket on the edge of the cylinder in detail. So we're going to click, you got to click the silver area right here. There we go. Make sure you click the silver part. If you just click the black part, it's not going to work. And now you're going to see a close-up. There's actually a bead inside of there which gives it the strength so that the pressure doesn't push it out of the way. So it kind of wraps around it, and then you got the bead going in the middle. We'll go to number 4 now. Find the following components in the close-up. So the first thing it wants us to find is the steel edge. That's going to be this part right here. Find the bead core. That's going to be this round part there. The graphite gasket material is going to be the black part. And then the metal core, and that's what gives it more strength right here. And now we'll go to number 5. Click a coolant passage in the head gasket to view it in detail. So now we're going to select one of these green lines, and it doesn't matter which one you select, but we're going to click on one of these green lines. There you go. And now what you're going to see is the rubber piece there that provides a sealing surface. And we'll go to number 6. Find the following components in the close-up. So the rubber ring, that's going to be this part right here. It's actually a piece of rubber that seals to the metal. The graphite disc material is going to be the black part. And then once again, the metal core is going to be the center that gives it more strength. Now we'll go to number 7. This time we're going to click on an oil passage in the head gasket to view it in detail. So now you'll see all these little kind of reddish or brown lines. That's going to be where the oil goes through. And you have to make sure you actually click right on the head gasket, one of those little circles. It could be that one or this one or this one. But make sure you click on that little opening. And we'll go to number 8. Find the following components in this close-up. So once again, we have a silicone ring. We've got the graphite disc material, the black part. And then we got the metal core that gives it strength also. And we'll go to number 9. Click the place that indicates the thickness of the head gasket. So right over here, it talks about the number of holes, punch, or notches at the edge of the gasket are an indication of the thickness of the gasket. So right here, you're going to see that. So we're going to click on that area. Why are there different head gasket thicknesses for one type of engine? And that's going to be because after the head is machined, a thicker gasket is sometimes necessary. So as engine work is done, sometimes you need a thicker gasket to fill in that space that you might have removed from it. And we're going to go to number 11 now. So this one says view the warped cylinder head, and that's what we're seeing right here. It's an extreme view, but you get the idea. So the block is flat, but the cylinder head is actually sitting on an angle, which is letting my coolant sneak out, and that would cause a coolant leak. So the question is, why must the cylinder head be completely flat? So we have no unwanted leaks between the block and the head gasket. So there's a lot of places we could have leaks, but this is the one case where we don't want leaks in regards to the head gasket. So I'm going to check that one. There we go. All right, we're going to go to number 4 at the top. Number 4 talks about cylinder head bolts, and we'll read through this. It says cylinder head bolts fasten the cylinder head to the block. The clamping force is very important. This is the force that holds the cylinder head to the block. The cylinder head bolts are heavily loaded during the power strokes, as the gases expand inside the cylinder, forcing the piston downward. When installing a cylinder head, the cylinder head bolts must be tightened using the correct sequence to avoid warping the cylinder head. This tightening is usually carried out in multiple phases, so the difference in tension between bolts stays as small as possible, ensuring a uniform and correct clamping force. So the first thing it's going to ask us to do is click on the cylinder head bolts. Now before we do that, right here we've got the engine block, the bottom half of the engine, and then up here we've got our cylinder head, the top half of the engine. And you can see right here we've got our bolt that goes all the way through the cylinder head and then threads into the block to basically secure the cylinder head to the block. So you're going to see there's a lot of threads right here because it needs a lot of strength to hold that down. So go ahead and click on the bolt right here, and now you're going to see a close-up of what it all looks like. We'll go to the second one, and it's going to ask us to select some different parts of the bolt. So the head of the bolt is going to be right here. That's going to be the top that you would put the socket on to tighten it. We have the shank of the bolt right here. It's going to be the long part. The screw thread is going to be the threaded portion down here. And then we've got the washer up at the top. And we'll go to the third one. Now we're going to watch the animation. So this is kind of a extreme example, if you will, but it animates what actually happens during the power stroke. So anytime you see a flame, combustion, what you're going to see is the cylinder head wants to lift up off the top of the block, and then you end up with a gap here where our combustion gases could escape, therefore losing power. So that'd be known as a cylinder head leak. So it's an extreme animation, but it gives you an idea of what's actually happening during every power stroke. And that's why this bolt has to be so strong to keep it clamped down so that that does not happen in real life. So as we watch the animation, when are the bolts loaded the most? That's going to be every time we see this flame, combustion. So during the power stroke. I'm calling it combustion, they're calling it power stroke. Two ways of saying the same thing. And now we'll go to the fourth one. All right, so this is where it gets a little tricky. We're going to start tightening these bolts down, but we got to do it in the correct order. So it says you will now tighten the cylinder head bolts. The required information is specified next to the cylinder head. Click the first cylinder head bolt, one that needs tightening. So if we look at our chart right here, this is going to be bolt number 1, then we'll go to number 2, 3, 4, 5, and 6, so on and so forth. So we're going to first select number 1. And if we look at our picture right here, that's going to be this bolt. So that's going to be the first bolt that we have to tighten. So this is our diagram to follow. All data, modal logic. This is going to be our actual bolt that we're going to be tightening. We're going to go to number 5 here. So it says always use a torque wrench to tighten cylinder head bolts. Adjust the torque wrench to the phase 1 torque specifications and then tighten the first cylinder head bolt only. If you make a mistake, click the reset button to restart the exercise. Refer to torque wrench lessons to review adjustment of the torque wrench. So here's what we're going to do. We first need to tighten it, phase 1, to 50 Newton meters. So we're going to grab the torque wrench and we're going to move it down to 50. Now, what I want to point out is you'll see 50 right here. You'll see the line, and it kind of does a little zigzag. You have to make sure the bottom of the plastic piece, the bottom of the black piece, is right at that line right there. Now, if you need to on your Chromebook, zoom in on this. You got to get it perfect. If it's not perfect, it's going to tell you did it wrong. So now that we've set the torque wrench to 50, we're going to grab our torque wrench. We're going to put it on bolt number 1, and we're going to very slowly, I can't say this enough, very slowly tighten it until you see this turn red. If you just start going crazy on it, you're going to over tighten it and it's going to tell you did it wrong. It's going to make you start over. You don't want to start over after you've done all 10 of these bolts. So we just did the first bolt through phase 1 of 50 Newton meters. We'll hit check and we got it right. Now we'll go on to number 6. After phase 1 is complete, a torque angle meter is used to set all bolts to the final torque. Only then is the proper clamping force achieved. Using the torque angle meter, which is this one right here, tighten the first cylinder head bolt according to phase 2 specifications. So if we look at phase 2 right here, it says 120 degrees is how much we need to tighten it. So we're going to grab the torque angle meter, we're going to set it on bolt number 1, and we're going to take this all the way down to 120. I'm going to ask you, what happens if you go past it? You over tighten it and you got to start over. So make sure you go really slow with this and take your time. If you have a mouse, it helps a lot to use a mouse on this. So we're going to get right at 120. And now we'll hit check, and we got it perfect. If you didn't get it right, you can just hit reset and do it again. Now we'll go to number 7. So now that you're familiar with the process, this time tighten all the cylinder head bolts in sequence, beginning with phase 1 and then phase 2. So we're starting over from the beginning. So what it says is for phase 1, we got to set the torque wrench to 50 Newton meters. So I'm going to bring this down so it's just above the top of that little line right there. And which bolt do I need to do first? I have to do number 1. So we'll go to the first bolt right here. We'll take the torque wrench, set it on there, and very slowly tighten it until it turns red. So that's the first one. Now I'm going to go to bolt number 2 right here. So we're going to take the torque wrench, move it across very slowly until it turns red. And now I'm going to go up to bolt number 3. So we'll move this up very slowly, tighten it till it turns red. And now I got to find number 4. It's going to be a cross pattern. That's the easiest way. That's how you do it to keep it even. So we're going to go number 4. Very slowly till it turns red. And now we're going to go across number 5. Slowly again. And now we're going to go up here to number 6. And you'll notice it's a lot of X patterns. Tighten it slowly. And now we'll find number 7 down here. And now we're going to go all the way up and across to number 8. Slide across to number 9. And then we'll go down to number 10, last one. There we go. So we'll put this back, and now we got to do this again, but we have to do it torquing it to 120 degrees in the same order. So we're going to grab a torque angle meter, put on number 1, and very slowly, I can't say it enough, go really slow with this and get it perfect so you don't have to start over. There's number 1. Now I'm going to move it to number 2. And one of the other things I'm going to do while I'm thinking about it is move this back to 0 because it yells at you later if you don't. Move this down till we hit 120. And now we're going to go up to 3. Crank it down to 120. And now we're going to go across to 4. Stop at 120. Slide across to 5. You guessed it, 120. And then we're going to go up and across number 6. Right there. Now let's see if it yells at me for that. It might. I went too fast. I went over 120. It might yell at me for that. It might make me redo this. Let's see what happens. All right, we're going to go from number 6 across and down to number 7. Going very slowly to make sure we don't go past 120. There we go. We're going to go up and across number 8. Very slowly, stopping at 120. Slide across number 9. And finally, down and to the right for number 10. Stopping at 120. Put that back, and now we'll hit check and see what happens. And we got it. If it says you didn't do it right, just hit the reset button, go through and do it again. Yes, it sucks. Yes, it takes a little time, but if you're doing this in real life, it takes significantly longer to do. And if you do it wrong, you end up with an engine that might not be working right. So now we'll go to number 8. Why is there a tightening sequence for the cylinder head bolts? And that is going to be so that they are uniformly clamped right here. So you get uniform and correct clamping force, because the cylinder head must be clamped uniformly to the block. So that's one we're going to go with. And now we'll go to number 9. Why must the cylinder head bolts be tightened using multiple phases? And that is going to be so we avoid warping and we get that uniform clamping force. So clamping force is correct clamping force achieved, yes. Cylinder head can be clamped uniformly to the block, that's also true. So the cylinder head bolts don't break, that's going to be false. So the cylinder head bolts stretch as much as possible, that's also going to be false. We don't want them to stretch as much as possible. They will stretch, but we don't want them to break. So these first two are going to be true. All right, I realize this was a long module and can be a little frustrating if you didn't go really slow and carefully, but that is how you tighten the bolts down to install the cylinder head. If we were in class, this is what we would be doing. We'd also be using a tool just like this to do the angles on them the exact same way. All right, we'll hit number 10 here so we finish the module and we can call it done. All right, thanks for getting this done, guys. Talk to you later. Have a wonderful day.